Hello, I am Dr. P. Kumar, working as Associate Professor in Department of Civil Engineering, Sri Krishna College of Engineering and Technology, Coimbatore, Tamil Nadu, India. I am going to present about the strength and durability characteristics of high strength recycled aggregate concrete. It's a small experimental work presentation. Environment posing lot of challenges to our society. The construction industry demands a significant amount of natural materials in order to produce cement and aggregates. Utilization of recycled aggregate from crushed concrete waste as alternative to natural aggregate in construction industry solve the construction and demolition waste disposal problems and reduce the gap between the demand and supply. It conserves the natural resources and reduces the space required for the landfill disposal. Sustainable waste management is another issue faced by the countries all over the world. Many research works have been carried out so far to investigate the possibility of recycling of concrete waste. None of the previous results indicated that the recycled aggregate concrete is unusable or unsuitable for structural applications. The strength characteristics of concrete containing recycled aggregate are generally lower than the concrete made with natural aggregates. This is because of the adhered mortar over the recycled aggregates. So this research presentation presents the experimental results of various percentage replacements of recycled coarse aggregates, and finally we are compared with the natural aggregate. We are trying with high strength concrete. The main objective of this work is to assess the effect of recycled aggregate replacement on the characteristics of high strength concrete. So finally we try to find out the optimum mix combinations. So this is a simple methodology we are following to find the optimum mix combination for the high strength recycled aggregate concrete. Here we are selecting M50 grade, and we have chosen 4 different mix combinations consist of natural aggregate concrete and recycled aggregate combination of 25%, 50% and 100%. Here we are trying to find out the mechanical as well as the durability characteristics. So strength characteristics like compressive strength and tensile strength using tubes and cylinders we are trying. And for durability characteristics, we tried with the sortility test, rapid chloride penetration test and acid resistance test. Finally, we studied the effect of age of concrete in the different ages like 7 days, then 28 days, and finally 56 days and 90 days, like that. And finally, the effect of recycled aggregate replacements also studied. The final results are compared with the natural aggregate concrete, and the percentage differences and suitability of replacement of recycled aggregates was found out. So these are the material properties used for this research work. So ordinary Portland cement was used, and the specific gravity of the cement is 3.12, and ordinary fine aggregates obtained from the rivers, and coarse aggregates, recycled aggregate having 2.7 specific gravity is used for this work. So recycled aggregates are retrieved from the demolished building of age more than 60 years. So the maximum size of the aggregate, here we are using a 12.5 mm size. We reduce the water cement ratio by using the chemical admixtures Conplast SC430. The mix proportion we found as 1:2.77:2.32. Here we tried with the various mix proportions, and finally we obtained the combination of 1:2.77:2.3. The water cement ratio for this is 0.35, and we reduced this water cement ratio by adding super plasticizer, and for the workability of 78 mm slump value. tried with the tube specimens, cylinder specimens for conducting the experiments. The tube size is 150 mm by 150 mm or 150 mm, and cylinder size is 150 mm diameter by 300 mm diameter. For doing this RCPT test and other RCPT test, we tried with a cylinder of 100 mm diameter with a height of, it's a slice cut from the 300 mm height cylinder. So 50 mm height we are maintaining for the RCPT test as well as the RCPT test. Now we are going to see the results and discussion for the various tests. Regarding the compressive strength test, here we found an encouraging trend was observed in the compressive strength with a reduction cost and eliminating disposal and the environmental pollution problem. So compressive strength of recycled aggregate it gets reduced irrespective of the age when percentage of replacement increases. Only lesser value of reduction in the compressive strength was observed at the earlier ages. So here we observed at the earlier ages for 7 days it is 19.91 is the 100 for 100% replacement, that is the strength we obtained, and at the age of later ages finally the percentage difference is 36% for the 100% replacement, and for 23% replacement we got 19%. So the percentage decrement gets reduced when the age of the concrete increases. From the above results, it was very clear that the recycled aggregate could be used as a structural concrete with some modifications in the mix design. In mix design, for achieving the expected strength, the cement content may be increased and the sump must be checked for the workability. So the adhered mortar over the recycled aggregate also should be cleaned. So the treatment of aggregate also will give you better strength results. Similar sort of results was obtained in the tensile strength. Here also only lesser value of reduction in tensile strength was observed at the earlier ages, and the percentage reduction in the tensile strength of concrete was observed as 5% to 26% for the 25 to 100% replacement. And at the age of 28 days, it increased to 15 to 35% for 25% to 100% replacement. But the percentage decrement in strength gets reduced when the age of the concrete increased. At the age of 56 days, it was observed as 6%, 20% and 23% for 25, 50 and 100% aggregate replacements respectively. So from the results, it was very clear that the recycled aggregate could be used as a structural concrete with some modifications in the mix design. Would also depend on the size, distribution, interconnectivity, shape and tortuosity of the pores, etc. In recycled aggregate concrete, the increment may be due to increase in the water absorption capacity of recycled aggregate because of existing mortar adhered even after the cleaning. Now the effect of recycled aggregate on the RCPT test. So here we tried with the various mix combinations, 25%, 50% and 100% replacement of aggregates. During the earlier ages, the water absorption is very higher, because we know that the recycled aggregate has more porous than the natural aggregate. So the water absorption also will be very higher in the initial stages. But in the later period, it gets reduced and we got very good results. From the results, it is understood that the total charge passed through the recycled aggregate concrete cylinder is greater than the natural aggregate concrete cylinder. So obviously the chloride permeability also increases with the increase in the percentage replacement of recycled aggregate. So but everything is in the limit only, because even for the 100% replacement also we got only 3627 coulombs only. So that means that it is in the permissible limit, and it is chloride ion penetration permeability is in the moderate range as per the RCBT test. Now let us see the alkalinity test. So alkalinity and resistance against the hydrochloric acid and the H2SO4. So the value of compressive strength was compared with the specimens cured in water and the H2SO4 solution soaked specimens and HCl cured specimens. The compressive strength obtained for specimens cured in H2SO4 are comparatively lesser than the strength of concrete specimens cured in water. But it can be seen that the specimens are having relatively greater strength than that of the concrete specimens cured in 0.1 normality of HCl acid. The pH value also one of the important factors to influence the rate of corrosion. The normal pH value for the concrete to passivate the reinforcement against corrosion is 12. If the value comes below 9, the carbonation of concrete takes place and the corrosion also gets initiated. So the general pH value of the solution and the level of inducing corrosion in concrete was tested, and from the results it was very clear that the effect of H2SO4 is very higher than the HCl. The replacement of recycled aggregate decreased the resistance against corrosion in all kind of solutions. So finally we found that the possibility of corrosion is high in the 100% replacement of recycled aggregate concrete when it is subjected to H2SO4. So finally we conclude like this: the aging of the specimen increased the compressive and the tensile strength irrespective of the replacement percentage of natural aggregate with recycled aggregate. The rate of reduction in the compressive and tensile strength increases up to the age of 28 days and decreases for further increase in the age. The percentage of reduction in compressive strength of concrete due to replacement of recycled aggregate ranges from 19 to 36%. When natural aggregate replaced with 50% recycled aggregate, the compressive strength obtained was around 35 Newton per mm square, which is almost 70% of the characteristic compressive strength and is acceptable for structural concrete. Hence, it is suggested that natural aggregate can be replaced with 50% recycled aggregate in the field, and it can be very well reduce the cost of construction and minimize the environmental disposal problems. Thank you very much. Thank you for giving me an opportunity to present my experimental work. Thank you all. Thank you very much.